for graphics, right? So you should not miss any topic, as I told you. At least learn something. Something is better than nothing, always remember. So let's do the PYQs for 2025 December. By looking the question, you will understand that yes, what are the topics are important, and according to that you can prepare yourself. First question you can see here, which of the statements are true? Actually, in computer graphics, this is only here. So many algorithms related to different types of technique they are asking. And what are the most frequent algorithm? I will suggest you, before starting only, take your pen and paper. How to prepare for graphics? Easy way I am telling you. Take your pen and paper, and from here the question, you will see the algorithm names, right? Write down those names and start making star. Like see that here, Painter's algorithm, Gouraud shading, these algorithms are there, right? You write here Painter's algorithm. Now give 1 star. After that, when next question, again you will see Painter's algorithm, give another star. Again Painter's algorithm, give another star. Like this way, with the class, you will understand what are the algorithms are most repeated. Same name, same algorithms, multiple time repeated. Gouraud shading, Z buffer, Gouraud shading. By looking the star, you will understand that okay, these are the algorithms repeated most, and other than that, these algorithms are there. So something idea about the algorithm, yes, what it is, the where it is using, how it is using, that is enough for computer graphics. Okay, take your pen and paper. Take your pen and paper, you will get the idea. After the class, you will prepare your own notes and you will be ready for graphics. ठीक है? ठीक है? Okay? Take your pen and paper and read the question. Try to answer. Those who know, that's okay. Those who don't know, they will learn. They will also learn. Don't leave the class till the end. Watch it so that definitely you can confirm your score from computer graphics also. Your time start now. Read question, write it down and learn. See what are the topics and how to understand. Painter's algorithm, Gouraud shading and Z buffer. Painter's algorithm is also called as depth shot. Here it is given Gouraud shading is interpolating shading method. Gouraud shading is averaging shading method. Z buffer algorithm finds the largest depth value of Z. Understand the topic, what is true and which is false and why. Understand that, and you can take your notes also about this algorithm, very important algorithm. Painter's algorithm is called depth. Here Painter's algorithm, draw the object from back to front. This is the main topic. Next time when you will see the Painter's algorithm, I need correct answer from everyone. Okay, so write it down. It is for drawing object back to front. The object are sorted according to the depth before rendering. Because for every object there is a depth, right? Like whatever object you are taking, if you are taking, this is a object. So what is the depth? This is the depth. So it is counting the depth, where the depth, how we have to do. So it is according to the depth it will render, and hence it is also known as depth shot algorithm. So that's why it is true. No problem. This is true, that's why. Clear? So Painter's algorithm, these are the topics only you write. Okay, about Painter's algorithm. Back to front, and it is measuring the depth fast. That's why it is called depth shot algorithm. Next one is Gouraud shading. Gouraud shading is shading algorithm method. We are doing shading for any object. You are doing shading like this. Now at the time of doing shading, there are two algorithms related to shading. One is Phong shading, another is Gouraud shading. Write down it, Phong shading and Gouraud shading. Very important. Many questions you will see from here. So about Gouraud shading, how it is doing shading. First of all, illumination is calculated at the vertices. Each and every vertices you know, node, vertices we learn in graph. So for each and every vertices, it will calculate the illumination. Means illumination is what? Illumination means what will be the brightness, how much color and all that is. So illumination, it will calculate in the vertices. Color or intensities are then interpolated across the polygon surface. Polygon means 3D object, right? That is called polygon. And therefore the Gouraud shading is interpolating shading algorithm. Because of that only it is called interpolating shading algorithm, because it is interpolated across the polygon surface. That's why. So that's why this is also correct. Gouraud shading is an averaging shading method. No, this is not averaging shading method. It is interpolation, not the averaging. Means every vertices you are taking care. That's why it is not a averaging shading method. So this is wrong. Z buffer algorithm. This is another important topic for you. What is Z buffer algorithm? Z buffer algorithm find the largest depth value Z for any object, like maybe it is a 3D object. For this one, what is the largest depth? That is counted by Z buffer. So largest depth, it is correct or false? No, it is not correct. Because why? Because Z buffer keeps the nearest visible surface at each pixel. For each and every pixel, which is the visible area. See, whenever you are taking a 3D object, some part is visible, some part is not visible. See, this is the object. Some of the part is visible, some of the part is not visible. Yes or no? Right? Yes. So what the target of Z buffer algorithm? It is trying to see from this pixel what is the nearest visible point. That is the task of the Z buffer. So typically the pixel with the smallest depth closest to the viewer is retained. Therefore, it does not find the largest depth value which is visible to you. According to that, it will be calculated. So it is not calculating the largest depth. That's why this one is false. Clear? Write down the important areas. Okay. So from here you are able to understand A is true, B is true, C and D is false. After checking all the PYQs, we will combine these all algorithm as a mind mapping so that you will be ready for exam. Okay. Yes. So here this is the way, key idea how you have to make the prepare the notes. Pentar's algorithm, back to front rendering, depth shot, Z buffer, keep nearest surface for each pixel, Gouraud shading, vertex illumination plus interpolation, Phong shading, normal interpolation per pixel illumination. You will see Gouraud shading, Phong shading is the related topic. Just now you will see another question also. So Phong shading also, remember, it is doing normal interpolation plus per pixel illumination. Okay. Now come to the next question. So that's why A and B is the correct answer for this question. Next one, see this. Assertion and reason. Curve related. Very, very important. Bezier curve, cubic curve. Very, very important topic. Again and again they are making question from this topic also. Some of the topic are very much repeated area. Bezier curve. Many times you will see question from here. Read, think and answer. This topic only repeated many times. Yes. See that Which one is assertion and reason? Nowadays very popular. So how to understand? Assertion is given the control point have only local control over the shape of the B-spline. So it is asking about B-spline curve. There are different types of curve. One is Bezier curve, another is B-spline curve. Multiple types of curves are there. So Bezier curve do not have the local control. In light of the above statement, which one is appropriate here? First one, it is given about the B-spline curve. What is how it is working? Curve means what? You are drawing this type of curve. This is also curve. This is also curve. These are called curve, right? Whenever we are drawing in graphics, then how it is drawing, that is the meaning. So the B-spline curve, moving a control point affect only a portion of the curve. Okay, it's properly called the local control because only a particular area it is focusing. That's why it is called local control. Bezier curve changing one control point does not alter the entire curve. It is Bezier curve is focusing on the total one, but B-spline is focusing only the local on a particular area. Like if I am drawing this curve, maybe it is focusing on this particular area, not the total area. That's why this is true, that the control point have only local control over the shape of the B-spline curve. Okay. Next one, Bezier curve do have the local control. That is wrong because Bezier curve, whenever you are doing the Bezier curve, remember the topic about the Bezier curve. If I am taking this type of curve, here the control point will be like this. Maybe it is the starting point, it is the ending point. About Bezier curve, always remember it is passing through only starting and ending point. Many questions came from here. And these are the two control point. It will just like maybe here, it will just for stretching that. Means how the curve shape. From this control point, you have to think like that. I am just stretching the curve so that how the shape will be. But it will not pass through that control point. You are taking a string, you are stretching the string to get the shape of the curve. Okay. That's why here global control means how the total shape of the curve will be, that is controlled by the Bezier curve. And remember, Bezier curve is going through only starting and ending control point. Remaining points are there to make the shape. From here also question came. That's why this is wrong. Reason is wrong. So assertion is correct, reason is incorrect. So your answer is this one. Okay, clear? So here you are getting the answer. A is correct, reason is incorrect. Now as a numerical, for now I am leaving this numerical. First do these theories, after that I am coming to the numerical. This numerical will take little bit time. So we will come back to the numerical after doing the theory easy question. First let's complete the theoretical question, then I am coming to the numerical question. Okay. Do this one. Clipping. Most repeated area. Most repeated area, clipping. Direct question from clipping and related algorithms, list of algorithms. Which one is working? That list is very important. Which of the following technique used for clipping? This type of question also you will see. And that's why you need to make a list of, okay, these are the clipping algorithm, these are the shading algorithm, these are surface shading algorithm. These are like line drawing algorithm. These are circle drawing algorithm. The list of name is only important. So from here you see which one? Sutherland, Cohen-Sutherland algorithm, most popular algorithm. Sutherland-Cohen algorithm is a line clipping technique used for computer graphics. It is asking you that for clipping, it is a line clipping technique used for computer graphics. That's why this is the correct answer. This one, and this one, any one of them. See that this is scaling, this is not clipping. Directly you can eliminate also. So Cohen-Sutherland is the line clipping algorithm here. Very popular. Next one you see projection. This is also very important topic. Next topic is projection. Different types of projection. Oblique projection, cavalier, cabinet, orthographic. Most popular topic. Read and match. Graphics area is repeated. That's why within 1 or 2 days also you can learn the graphics. What of the topics are most repeated? Easy area. Yes. See that, what about this projection? Projection means what? You are looking a 3D object. In front of you, you are looking a house and all like a scenery. Now, how you will project it into a 2D? Okay, because we are looking, but how to represent that? That is called projection. So here, these are the different types of projection technique. This is your answer. Why this is your answer? First one is oblique projection. What is oblique projection? Oblique projection is the projector line of the side are parallel to strict projection plane of the oblique angle. That means like maybe you are going to draw a house, it is looking like that. Your projection object will be exactly in 90-degree angle. Exactly with 90-degree angle. That's why here when the angle between the projectors and the plane projection is not, it is not exactly 90-degree, it is parallel. It is not 90-degree, it is parallel, but strike on the oblique angle, not 90-degree. It is not 90-degree, it is parallel to this. That's why this is your answer. Next, cavalier projection. Cavalier projection means the cavalier projection is a type of oblique projection only. There is a chart of different types of projection. Please watch the projection class. You will see that it is one type of oblique projection where line is perpendicular to the viewing angle and draw the true scale, full scale. Like when we took an example also, like whenever you are drawing this type of stairs, then exactly total full length, half length, according to that the name is changing, right? So whenever you are taking the full length, please watch the class, complete class, then you will understand better. Then it is called the cavalier projection. Next one is cabinet projection. Cabinet means cabinet projection is also one type of oblique projection where line is perpendicular to the viewing plane, but it is taking half scale. Means the total stair, you will take the half of the part. That's why it is called cabinet. Next one, orthographic projection. Orthographic is what? Orthographic projection used parallel projector that can be perpendicular 90-degree to the projection plane, resulting the true two-dimensional views like top, front and side views. Means one house, like true shape means like you are going to draw a scenery like this, so you will feel it realistic. It is not a 3D, it is a 2D, but you will feel the realistic one. That's why it is called orthographic. When the direction of the projection is perpendicular to the plane of the projection, then it is called orthographic projection. Graphics you need to understand with the reality because you are drawing it. Graphics means what? You are drawing it, right? A total universe in front of us, from where you are looking it, how you are drawing it, how you are projecting it, that is only graphics, nothing else. So you need to relate, okay, you need to visualize what is happening. So this is your answer. All these projection you will see again, repeated questions are there. Now come to the December 2024. Every year 2 to 3 questions, not more than that. Now you see one question here. The light given by the phosphor during exposure to the electron beam is known as what? So it is known as, first one, two topics are there. One is fluorescence, another is phosphorus. So fluorescence is a type of luminescence where the substance emit light after absorbing energy like an electron beam. So first it will absorb the energy, then it will show the light. That is called fluorescence. Here in phosphors are the material that can absorb the energy like an electron beam and then re-emit the light. Okay. So that's why here your answer is fluorescence, because it is asking light given by the phosphor during exposure electron beam known as fluorescence. Here it is not phosphorence, it is fluorescence. Next one, the major adverse side effect of scan conversion. Whenever you are doing scan conversion, then what is the side effect in scan conversion? What are the side effect here? See, main side effect, it is given staircase, unequal brightness, packet fence problem, rasterization, pre-filtering and post-filtering. So understand one by one. Staircase appearance means what? I am going to draw a line. This is a line. The line should be like this, but the line is coming like this. This is called stair conversion. Okay, you are not able to draw exactly smooth line. You are getting like staircase appearance. This is called aliasing. When a line is converted into pixel, because you are putting the pixel small, so you are not getting the smoothness, getting like a staircase, and it is happening. That is called staircase appearance. Unequal brightness of the slanted line. Somewhere you will get more bright, somewhere less bright. Like this is more bright, this is like faded. Like if I am taking a light color, it is like faded. So brightness matters for a slanting line. This is also correct answer, no problem. Unequal brightness. Packet fence problem. What is the packet fence? This refers to the aliasing effect where the parallel lines, when converted into pixel, are appear as unevenly spaced or distorted. Reassembling called a packet fence. Okay, like I am going to draw the parallel one, but it will create the problem. That's why it is called packet fence problem. Next one is Rasterization. What is rasterization? While rasterization, main problem is aliasing. Main problem that you are getting that aliasing at the time of straight line, but when it is parallel, it should be same event space, but because of aliasing, maybe you are getting little bit. Space is not even. That is called here packet fence problem. Okay. Next one is rasterization. Rasterization is the process of scan conversion. It's not adverse side effect. It is one way. Rasterization, randomization. Two topics are there. Rasterization and randomization. It is a technique. It is not a disadvantage. That's why it is the process that causes the side effect. For why the side effect is happening? Because of this. It is not directly a side effect. And pre-filtering and post-filtering, it is a technique, because if I am doing pre-filtering and after drawing if I am doing post-filtering, then these disadvantages like staircase, unequal brightness, packet fence, this problem we are able to resolve. So it is the way how we can resolve. It is not the problem. So it is technically used for mitigation the side effects, scan conversion, not the side effect themselves. That's why which one is your answer here? You are getting this A, B and C. This is not, this is not. These three are the main side effect of the scan conversion. Note it down from the topic, just note it down, revise it. It will be good for you. Clear? Clear? Understanding? Now see, in the August 2024, there was no question. All the question was from programming. This type also happened. Not a single question was there from computer graphics. June 2024, you know, this was a drop paper, but still I have taken the question because this exam was cancelled. That is not a problem, but we will learn the topic. Do the question. Line drawing, about the line drawing, they ask the question. Read it and do the answer. List of algorithm is important here. This is a direct question. If you know the what are the algorithms we are using for line drawing, then directly you can answer. Definitely see that carve algorithm, it is not a line drawing algorithm. You can directly eliminate. DDA and Bresenham is very popular two algorithm for line drawing. So A and B is the correct answer. So now come to the December 2023. You see very limited questions are there from graphics. Here it is a numerical. I told you that we will come to numerical after doing the theory, because numerical will little bit time taking. First do the all theory question, then we will focus on the numerical question. Showing you the theory again. See that you have to match all the algorithms name, matching from the algorithms name. Match it and give me the answer. Yes. See here. Here you can directly mark also by doing elimination. That's why if you know something, then matching is easy for you. Bresenham algorithm. Bresenham algorithm is a line clipping algorithm? Not at all. It is a line drawing algorithm, right? So A will be with 2. You can see this one is not your answer. You are getting this one. After that, Cohen-Sutherland algorithm. This is also very popular algorithm for line clipping. Most repeated area. So it is a line clipping algorithm. B with 3. This is not your answer. This is already not your answer. Here you got. After that, this Z buffer. You saw this topic previously also. You saw the question from Z buffer. So Z buffer is hidden surface removal algorithm. Whatever visible to you, you are focusing on that. So it is a hidden surface removal algorithm. So your answer is this one. Repeated, you will see some algorithms are every time repeated. If you focus on that, and the next one is Sutherland-Hodgeman algorithm. This is a polygon clipping algorithm. Make the list. Line drawing algorithm, these are the line drawing algorithm. Whatever question came from there only you make the list. Hidden surface removal algorithm, this one. Line clipping algorithm, this list. Polygon clipping algorithm, this is the list. Okay. Next question you see, this one. This is not a numerical, conceptual question. Try to understand, then I am explaining. Obscure. I am giving you a clue also for obscure. What is the meaning of obscure? I am taking this 2 remote. The 2 remote in front of you. So you are able to see both remote, right? But if I am taking this remote here, can you see? Can you see the second one? You are not able to see the second one. This is the meaning of obscure. Means one object is hiding another object. Because this object exactly here, that's why you are from your viewpoint, you are not able to see. That is the meaning of obscure. Okay. Now, try to think about the line and give me the answer. Pure math graph concept means geometry concept. If you are strong in geometry understanding, then it is easy. I am explaining you, you will understand very easy way. These are the 3 points given to you, point 1, point 2, point 3 and the viewpoint means from where you are observing it. Right, this is your viewpoint and these are the 3 points given to you. And it is asking about obscure, which one will obscure from where. See that, how to calculate, how to understand it. The point C, this is your point C, that is viewpoint, means it is your eye point from where you are observing it, right? This is your eye point. Now from my viewpoint, if I am calculating P1, that is the CP1, the point is collinear, the point that is closer to the viewpoint, means which one is closer to your viewpoint. This is closer to your viewpoint, I am hiding it like this. So that's why you are able to see this one but not this one, right? So which one is closer to your viewpoint will obscure the further one when seen from the viewpoint. Means it will hide the another one, that is the meaning. So how to calculate it? We will calculate the vector CP1 vector. 3 vector we are calculating. First one is CP1, CP2 and CP3. How to calculate? Directly, like 3 points are there na. You think it x, y, z. So x2 minus x1, y2 minus y1, z2 minus z1. Simple, like that we can do. So here we are getting 1, 2, 10. Here we are getting 3, 6, 30. And here we are getting 2, 4, 6. With C you are doing with P1, then you are getting CP1. With C you are doing with P2, you are getting CP2. With C, you are doing with P3, you are getting CP3. It is clear how we are getting the vector? Yes, just do the difference and get the vector. Right, easy? Just do the minus and get it. Now see, now why? Because see that when I am taking this one and this one, you are able to see, but it is hiding means it is in same line. Why? Because when one is in same line, collinear, same line, then only it is hiding. So how to understand the same? Same means like if you are multiplying the value, then if you are getting same, you see that relation between these two, this one and this one. If you are multiplying with 3, you are getting here 3, 6 and 30. That means CP1 and CP2 is collinear. Got it? 2 multiply into CP1, you are getting, if you are doing 3 multiply into CP1, you are getting CP2. So which one will obscure? P1 obscure the P2. Means if view from C, then you will able to see the P1, you will be not able to see the P2. Because P2 you are getting by multiplying with P1. That's why this is your answer. Clear? Any other one, P3, you will be not able to see the multiplication will not happen. With this one and this one exactly same value you cannot multiply. This one also you cannot multiply. So these are wrong. Okay. So your answer is coming here. That's why first point is given. P1 obscure P2 if viewed from C. That is correct. Next one, P2 obscure P1 if viewed from C. This is wrong. P3 does not obscure P1 because you are not getting any multiplied values. So this is also correct. And P2 does not obscure P3. This is also correct. So these are correct here. Be careful here. You will be able to understand, okay, I am able to multiply, but P1 will obscure P2 or P2 will obscure P1. Here only will get mistake. So which is near one? That will obscure the further one. So this is the main value. Here it is the multiplied value. So the main value will obscure the multiplied value. Okay. So that's why here be careful that P1 will obscure P2 because P2 you are getting by multiplying something with P1. Okay, clear? Obscure is clear to everyone? Easy concept. Now see, Ho. What is Ho? It is a direct question. If you know the topic, then you can answer directly. These terminologies you can note it down. You are getting some terminologies which is important for graphics. Ho of the color related to its wavelength. Why? Because Ho means we have different color, right? So the Ho is the color pixel is one of the very fundamental one where it is in digital image processing along with saturation and the brightness. Means red color, different red versions are there. Some brighter red, some dull red, some brownish red, orangish red, multiple red versions are there, right? If you are taking this plate, you see that multiple red version, multiple yellow version, multiple blue version. That means, yes, because of the brightness and all, The colors plate are different. That is the Ho here. So this is because of slightly different dominant wavelength. For each and every color have a wavelength. Because of the wavelength, this is changing, and this is called Ho. This is called Ho. Okay. So the pure Ho completely saturated, meaning no white light is added. Exactly red. You are not adding any white color, white light. Okay. So Ho, it is in the context of color and graphics, so it is focusing on the wavelength. So that's why your answer is wavelength here. Clear? Now come to the June 2023 question. See, it is asking about different techniques, direct question, easy question. See here, which of the following transform in 2 dimension use resize a dimension? I am doing resizing. Resizing means exactly scaling. Scaling is what? You can increase the size, you can decrease the size. Scaling concept is that I am multiplying the value, right? Translation means you are shifting a point here to here. That is called translation. Rotation means it is with angle. It was here, you are changing the angle. That is called rotation. Scaling is that it is maybe your object, you are zooming it, or you will zoom out it. When you are multiplying with greater than one value, then it will zoom, it will size will be bigger. If you are multiplying with less than one value, then size will be smaller. Scaling is very important topic. X value, Y value, you are multiplying and you are getting the scaling factor. So that's why answer is scaling. Shearing means it is changing the shape. Changing shape also. Not only means size, changing shape also, because here the factor is different. So answer is scaling here. Now you see a direct question from scaling. Simple numerical, we can't say, simple question. Try to answer. Some ordering problem is there. Try to find out the answer. Some ordering is shifted, but don't focus on ordering, focus on the values. Okay, then you will get the correct answer. Multiply it and get the value. Very simple question. X factor and Y factor both are given to you. You multiply and get the value, na? Here it is given the x axis 3 and y axis is 3 and 2. So that multiply 2 multiply x and 3 multiply y. That is the simple. So here x and y, if you multiply, you will get 0, 0 itself. So 0, 0. Here if I am multiplying with 2, I will get 0. Here I am multiplying with 3 means I am getting 6. Here 6 and 0. Here I am getting 6 and 6. These are the values only I am getting, right? So obviously this is my answer. You are getting 0, 0 here. You are getting 0, 6 here. You are getting 6, 0 here. You are getting 6, 6 here. I already told some ordering problem is there. It should be 0, 6 and 6, 0. But values are okay. So this is your answer. Simple question, right? Why doing mistake then? That's why option 3 is the correct answer. Scaling means just multiply. Translation means just add. These simple formula remember. Translation, scaling and rotation. Okay. Clipping. Now see the question on clipping. What is exactly clipping? Everyone is taking photo from your mobile. Every day you are doing actually clipping. Whenever you are taking photo from mobile, taking pics. Yes. Removing object and lines. Clipping means whatever inside the frame. It is coming inside the frame. That is your clipping area. This part will be removed. This part will be also removed. Only this part is visible. This is called clipping. Inside the frame, that is only visible. Outside, that is not visible. Here 9 regions are there for Cohen-Sutherland clipping. Very important. How the clipping is going on. Must watch the video of clipping. Important area, how we are doing clipping. Easily you will understand it. Now see, Sutherland and Hodgeman. Already you learned the topic. Already I told you. Now I think I can get 100% correct answer. Sutherland-Hodgeman working in which area? Same repeated area now you will see. Same topic are repeated. I told you to make the notes. Still I am getting some wrong answer. Sutherland-Hodgeman method used for convex polygon, not concave. Convex. Now see again. Bezier's curve, B-spline curve, sweep representation and natural object. Already you learned Bezier and B-spline. From there only you can do the answer. Eliminate, eliminate, apply elimination. Here actually they ask application. They did not ask direct one. They asked the application here. Bezier curve painting drawing for CAD. We are using because Bezier curve is working with total curve shape. That's why it is perfect here. B-spline curve for bias and tension because particular area. That's why here. Sweep representation for 3D 3-dimension object that have the translation rotational symmetry. And natural object, what is called natural object? Like factoral geometry, application based. Where you are using which one? That question is here. Now you see March 2023 question paper. Easy question from scaling. Simple easy question. Just read, think and answer. I already explained you the concept of scaling. Just now I explain. Greater than 1 and less than 1. By applying that concept only you can do the answer. Think properly and answer. Read the statement very carefully, then do the answer. See here. What I told, whenever, easy concept, whenever you are multiplying with greater than 1, then it will increase, size will increase. You are multiplying with less than 1, then size will decrease. 0.5 means what? It will decrease. 1.5 means it will increase. Now which one is x, which one is y? This is your x, this is your y, right? X means what? This is your x axis, this is your y axis. So which one is horizontal and which one is vertical? This is called horizontal line, this is vertical line. So horizontally whenever you are doing, it will decrease, x will decrease. Vertically it will increase. Is it or not? And 1.5 means what? 1.5 means 3 by 2 or not? That is 3 by 2. So 3 half. That is 3 half. So it is given that decrease the vertical by 3 half. Is it decreasing or increasing? It is increasing. Increase vertical by 3 half. That is correct. Yes. Double of the horizontal. No. Half of the horizontal, because 0.5 means what? Half. So half of the horizontal. So that's why answer is B and D. Simple question. Don't do mistake here, na. Very simple area. So your answer is this one. Now see here, raster scan. Raster scan and random scan. Two topics are there. Here the question on raster scan. About raster scan, here is a assertion reason question. Raster scan device is a CRT device. This is correct. In CRT monitor, you are using that raster scan and used for television monitoring display. This is correct. Raster scan display, the picture is composed with the service of dot, because it was dot, and these dots trace out the series of the horizontal line. Television work in the similar fashion. This is also correct, and it is the correct explanation. Why? Because you are getting answer why we are using raster scan in CRT graphics monitor, because the CRT graphics monitor, the elevation is also working in same fashion. That's why you are using here the raster scan. That means you are getting exact explanation of why from here. That's why both are true and it is the correct explanation also. If reason is supporting assertion, then only we are telling that yes, it is correct explanation. Yes, so this is correct here. Random scan and raster scan difference is very important for you, must remember. Next one, you can see 15th March paper. Most of the areas you will be not able to see the 15th March paper. It was conducted particular some Delhi center. There was some problem in 11 March. Some of my student was there. There was some problem. So that's why again on 15th March they have taken the paper with different question paper. So there they ask this question. I am giving you always all the question paper. Do this. I explained this just now. In this class only I explained the topic. Recall and answer. All the important points I am giving stress on that and I am explaining, because I know those topic question came. If you listen, then you can answer. See that. In dash curve, the last and first vertices of the polygon lie on the curve and other define the derivation, order and the shape. It is exactly Bezier curve. Explain that. In the Bezier curve, if you are drawing this type of curve, then through the first and last line, and here is the control point, which is just to give you the shape. This is the concept of Bezier curve, right? So that's why definitely this is your answer. Very important. Write down this line in your notebook. Many times question came from this topic. Exactly this line, copy and write it down. Now see again application based question. where we are applying which one? Two D array, transmission device, binary image, 1D array. You have to recall the olden days, how the olden days was working. Recall it and answer. Yes. Here your answer is this one, because 2D array input, where we are using the 2D array input, that is in camera, because 3D you are showing as a 2D, right, in camera. So that's why it is your transmission device. Which one is a transmission? LCD, LCD monitor, transmission device. Binary image, inkjet printer, because dot 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 dot, either 0 or 1. Very olden days we use this inkjet printer. And 1D array input, that is your flat bed scanner. This was taking the one dimensional input. So that's why this is your answer here. 2022 PYQs from graphics. This is a direct formula given, and from this formula you need to find out what is this. Yes. Here, this is the transformation. It is not scaling, it is not shear. Very popular scaling and shear. These are the metrics are not using for scaling and shear. After that, here is homography and steganography. So, it is actually homography. What is homography? You can relate the homography with wide angle image. In your camera, there is an option of wide angle image, right? You are taking this type of wide angle image. It is just like a wide angle image. So, homography is a projective transformation between two plane. Okay, no, not mirror image. Wide angle, how it is mirror? It is not mirror image, it is wide angle image. Like you are moving your camera and then it is capturing the wide angle image, right? Yes, like maybe you are trying to capture a big area, but in one shot you are not able to do. So we are moving our camera and it is showing as a wide angle, just like that, wide angle image. Okay, so here alternative and mapping between two planar projection of an image. In other words, the homographic are simple image transformation that describe the relative motion between two images when camera or observer moves. We are moving the camera and we are capturing the wide angle image, right? That's why your answer is here homography. Okay, clear? Now see again another question from hidden surface removal. Direct question. Which one is working on hidden surface removal problem with minimal 3D pipeline? The algorithm name already you learned. Pentar's algorithm. Pentar's algorithm is working on hidden surface. Another one you saw that Z buffer, right? Pentar's. Pentar's is also working on hidden surface removal. So Pentar's algorithm. 2021 question numerical, as I told, we will do next class numerical. Do the theories and easy one, then we will go for the numerical. Do this. Oh, sorry. This is answer. Sorry. Do the question. Read carefully, think carefully, then answer. So here the maximum number of side that a triangle might have when you clip a rectangle viewpoint is 6. But I can tell you that it will not 6, it can be 7 also. By looking the image only you can understand. Here we are clipping this triangle with the rectangle. You are getting 7 side. That's why first option is wrong. Okay. And second one, in 3D graphic perspective projection is non-linear to the Z. It is correct, and it is a very important point, non-linear transformation. 3D perspective projection, perspective transformation is always non-linear transformation because it is not focusing on Z values. So it is true. You will see so many questions from perspective and parallel projection. Perspective projection, parallel projection, very very important topic. Must learn the difference. I took the class, what's the class? This is most important, so it is true here. Now see, this is again from Bezier curve. You tell me in Bezier curve how many star you got till now. At beginning only I told you, write down the algorithm name and keep on adding star. How many star till now you got? How many times this topic repeated? So you are able to understand. By adding the star only you will be able to understand what of the topics are most important for me. Yes. Here you can see that by drawing the picture only you can understand it. Here how many points are given? XY there are P0, P1, P2, P3. 4 points are given, right? So the 4 points are given to you and here the degree is 3. Degree is always number of control point minus 1. So number of control point is 4. So degree is 3 here. That's why it is correct. Now P half equals to 0.3. By drawing the picture it is easy to understand. Here it is 0, 0 point. Minus 2, 0. That means 1, 2. I can take here. This is minus 2, 0. Here I can take. This is 1, 2, 3, 4. Here also 1, 4. You can see that 2, 4. So 1, 2, 1, 2, 3, 4. Like here. Here is another point. And 2, 0. 2, 0. This is another point. And another point is minus 2, 4. This is another point. So how my curve will be looking like? My curve will be like this or not? Because you are stretching this from here and here. That means my curve will look like this. By looking that only you can understand that P half, that means exactly half of the curve passing through 0, 3 point. This is correct. So A and B is correct. Bezier curve PT may extend outside the convex hull. Convex hull means this one is your convex hull. How it will go to the outside? It will be inside only. This is your control point. Inside that only it is possible. Outside it cannot go. So by eliminating that also you can do the answer. It cannot go outside. It will be definitely inside. So it is your answer. Clear? Very important topic, Bezier curve. This numerical, as I told, we will do the next class. Do this. Padma. It's global. Global means what? Total shape you are controlling. Think once. Wait 1 minute. See, this is what? This is just a string, you can think. So from where I will stretch, the curve will look like this. See that? If I am stretching like this, the curve will look like this. If I am stretching like this, the curve will look like this. Is it or not? From where I am stretching, the curve is changing. See that? From where? Like this. Curve will change. But is it going outside of my hand? My hand is the control point. So curve can go outside of my hand. No, right? Control point inside my hand, not outside. It is changing the shape. Total global shape is changing by the control point, but it cannot go outside. Got it? Yes. Clear? Clear now? This is the Bezier curve. This is the Bezier curve. That's why here your answer is, here the question was, whenever we got the Bezier curve question, that was the question na, for Bezier curve. Which one is going? So, this is your answer. You got it? Clear? Now concept clear. Very, very important topic. So, that's why your answer is this one. The Bezier curve, PT extend outside the convex hull, not possible. It will be inside. You are controlling the point. Starting and ending will go, but top points you are just for controlling it. Okay? Now do this. This is actually a matching question. You have to arrange properly, read the question, match it properly. From orthographic projection, perspective projection, most important topic. Do the matching and give me the answer. After matching only you will be able to get the answer. In different way they ask the question actually. See here how to match. How to match it, see that. You need to write here, okay. 1, 2, 3, 4. 1, 2, 3 and 4. Write it, now match it. First one is given perspective projection, second one orthographic. So perspective is matching with which statement? A, B, C, D, out of which statement it is matching with the perspective one? You see that straight line map to straight line, it is not perspective. Distance and angle are preserved. This is not only perspective. Require the homogeneous coordinate in order to encode the linear transformation, because perspective is actually a non-linear transformation. If you want to make it linear, then you have to go for homogeneous coordinate. Then only you can make it linear. So that's why 1 is matching with D. Next one, orthographic projection only. Out of this remaining, which one is only orthographic? Far away object appear the same size of the closer one, because orthographic not depending on the distance. From far or near, same shape, same. So that's why this is matching with C. Next one, 3. Both orthographic and projective transformation. Which one? Both. Both is this one. Straight line are mapped to straight line. Straight line is not changing. Here many times you are doing mistake with parallel. Parallel is not parallel, that is different. This is a parallel line. Whenever you are actually observing a rail line, train line, it is looking like this. That means parallel line is not parallel. But straight line is straight. This is also a straight line, this is also a straight line. Don't be confused with the straight and parallel. It is looking straight only, but parallel is not parallel. Okay. So here in both, straight line is preserved. So that's why both A. Last one is the fourth one. Fourth one is telling you the neither orthographic nor projective. So neither orthographic nor projective means distance and angle are not preserved. Distance and angle you are not able to preserve in anywhere. That's why this is your answer. You are getting this answer. Clear? Clear? Yes. Got it? Wherever confusion was there, non-linear, linear, I know that is your confusion. Why it is the answer? Clear? D, non-linear, linear. Another confusion is perspective, homogeneous, same size, regulate depth. Yeah, clear? Whenever you are going with homogeneous, then only you are able to make it. Okay? Very important, this perspective projection, orthographic projection, again and again they repeat. So must go through it. Yes, now the next question again you see, Gouraud shading, Phong shading. First we started in 2025 also they ask from this shading. Again you see in 2020 also they ask from the shading. Read carefully and answer. Main focus in interpolation. How you are interpolating. That is the main focus. See. Here by elimination also you can answer. Gouraud shading require more computation than Phong shading. This is wrong. Phong shading giving you better result and Phong shading is more complicated than Gouraud shading. By eliminating option A only you can do the answer. Other than that, Gouraud shading linear interpolates the color intention pixel color at the vertices. Gouraud shading is working on vertices, that is correct. Phong shading interpolates over the normal vector specific at vertices. This is also correct. It is working on normal vector and it is shading linearly interpolates. B and C is correct. A is wrong. Okay. Now, See the question again from Bezier curve, cubic curve. See, the topic is related. 2025 question, whatever they ask, again you are able to see the repetition of the topic in 2020. Right. Just observe the pattern. Here, Bezier curve are the curve that interpolate their control point. Many times I told, yes, all the control point, not, it is not interpolating on all control point, it is going with starting and ending. That's why statement 1 is incorrect. Statement 2, cubic curve have 4 control point. Number of control point minus 1 is the order. So 4 control point means order is 3. That's why it is called cubic. That's why it is correct. So it is correct one. Okay. The small points you remember so that you can answer. Now see again question from perspective projection concept. Parallel perspective concept. Remember. Here the third point, perspective transformation is linear transformation. It is non-linear. It is not a linear transformation. Linear means going like that. No, it is non-linear transformation. Linear means this is called non-linear, right? It is not a linear transformation. So that's why option C, by eliminating option C only you can do the answer. By doing mistake? It is non-linear, it is not a linear transformation. So under the perspective projection, each parallel line does not stay parallel. Just now I took the example that actually your train line is parallel but you are looking like this. That's why it is not. So it is correct one. Applying the perspective projection in graphic pipeline to vertex involve dividing by z coordinate, because you are representing in 2D. Actually it is a 3D, you are representing in 2D. That is correct one. So A and B is the correct one here. Now see this. This will make your all transformation revision, all types of 2D transformation. Shear, scaling, rotation, translation, you need to match. Match it, check and match, and try to apply elimination also. Which of the following algorithm not used for line clipping? Not used for line clipping. See, Cohen-Sutherland line clipping algorithm, Liang-Barsky also, this is also Sutherland-Hodgeman. It is not a line clipping algorithm. This surface, right here, this is the list of that. You can see Cohen-Sutherland, Liang-Barsky, Nicolelli algorithm, Cyrus-Beck algorithm, first clipping algorithm, these all are the line clipping. Sutherland-Hodgeman is not a line clipping algorithm. Sutherland-Hodgeman, where we are using? What is the purpose of Sutherland-Hodgeman algorithm? We learn. Tell me. This is a numerical. We will do in the next class. June 2020, 2019 June. See again the question from Phong shading. Phong shading. Using Phong shading reflection, not reflectant, the strength of the specular height is determined by the angle between reflected vector and the view vector, from where the reflection is going on. Like it is like this. This is the light, and from here you are viewing, and this is the angle. This angle is actually telling you how much bright you are able to see. If you are exactly looking from here, that brightness will be more. If you are looking from here, then brightness will be less. This is called the reflected vector and view vector. Strength of the highlight. How much strength you are getting, right? Exactly same. That is the angle. So, answer is this one. Next, simple question. Read it and answer. Maximum doing mistake, why re? It is given mirror. Why you are doing mistake? Tell me. What happened? Question was, you read question carefully na. The question was 2 cross 2 matrix mirror. Any 2D point x-axis is rotation matrix. Mirror is reflection, right? How it is rotation? It is reflection. With x-axis, whenever you are doing here, it will be here. So it is reflection. How it is rotation? Using xy rotation is happening. Only with x-axis it is reflection itself. It is not at all rotation. And S1 was correct. That about this matrix 2 cross 2 reflection. This is with x-axis because -1 was here. That's why it is x-axis. Our matrix was looking like this. -1 is here. That means it is x-axis. So that's why S1 is correct, but S2 is false. So answer is only S1 is true, na? Why doing mistake? Here numerical we will do next. Theory. This is, I think, theory is there. Do this one. Again from the orthographic. After the class, make a notes on these topics, whatever you saw in the questions. Orthographic transformation, keep parallel line parallel. I told you, yes. Orthographic, keep parallel line parallel. It is correct. Perspective is not doing. Orthographic is doing. Orthographic transformation is affine transformation. This is also correct. What is the meaning of affinity? In Euclidean geometry, affine transformation means that is affinity. The geometric transformation preserve the line parallelism, but not necessary distance and angle. It is not preserving distance and angle, but parallelism is preserved. That is called affinity. That's why it is called affine transformation. From here you can get assertion reason also. Assertion can be like orthographic projection is affine transformation. Reason is given that orthographic transformation keep parallel line parallel. Then assertion reason both are correct and it is the correct explanation also. Because affinity, from this same question they can create a assertion reason. Got it? Why it is affine? Because it is preserving parallel. That's why it is affine. From here only you can get different question. Maybe they can prepare. Again you can see perspective parallel. For you next year, means the upcoming exam, this projection topic is very important because this year they did not ask. This year they did not ask this projection. So for you projection is very important. This is the last theory question for today. This is the last one. Yes. So here the perspective projection, further object from the center of the projection, the smaller appear. The distance increasing, it is getting smaller. From here you are looking a object that will be bigger. From here you are looking a very far object that will be smaller. That's why it is called perspective. Distance matter here. This is correct. Parallel projection equivalent to the perspective projection where viewer is standing infinity far away. Means viewer is not. So then both are same. You cannot think about the distance. So that's why both are same. Perspective projection do not preserve the straight line. It is wrong. perspective and your another projection, that is orthographic, both are preserving straight line but not preserving parallel line. Straight line and parallel line both are not same. So that's why R is wrong. P and Q is correct. Okay. Must prepare the notes on this topic. What are the topics you saw? Tell me how many star you got. Perspective projection, orthographic projection, Bezier curve, cubic curve, B-Spline curve, translation, scaling, and like raster scan, random scan, Phong shading, God shading. These are the topics only repeated, right? How many topics you wrote till now? Tell me. And all the algorithms, line clipping algorithm, line drawing algorithm, surface, hidden surface removal algorithm. If you make a topic list, you see topic list is very less, very limited topic list, from where mostly your questions are repeated. Till 2018 I show you. 2018 to 2025, I hope you already write the topic list. These are the algorithm and these are the topics are repeated. So must revise only 1 or 2 days if you invest, then also graphics will be covered as per your exam. Because more questions they are not asking, 3 to 4 maximum. Sometimes they are not asking also. So according to PYQs only prepare. That will be best. Right? Okay. Now you already learned the topic and you already practiced one time. Now I will say how to revise and how to assure your score. After this, you just revise the topic. After that, come to the PYQs test. In your app, Unify Study app, go to the app. Under the app, you will get the test series. Under the test series, there is the PYQs test series. Under the PYQs test series, all graphics question together, total 45 question test series is there. Okay, total 45, 90 minutes. It will be very much beneficial for your revision. Same question you will get, no problem. Same question. But your target will be 45 out of 45. All 45 question from PYQs, all question in one test. Because every year they ask very few number of questions. That's why we add all the question and we make one test series. Where 2018, 2015, I think some of the question we have added to mainly 2018 to 2025. Total 45 questions are there. Must attempt the test series. Not only graphics. For each and every PYQs, subject-wise, year-wise test series available. Unit-wise test series. For graphics, we combine all. But for other unit also, like unit 1, unit 2, every unit, year-wise tests are there. 10 question, 12 question, 15 question. Whatever they ask, we add those. Single, 10 minute, 20 minute, 15 minute. Whenever you have time, go to the PYQs and attempt the test. And even also the full length test is also there. PYQs full length test. 2018 to 2025, all full length tests are available under the PYQs. That will be a good and perfect revision. You go, invest your 2 hours time and attempt a full length PYQs. December 2025 PYQs, June 2025 PYQs. Those who are thinking that, ma'am, I am a paid learner, I am not getting PYQs PDF. It is there. It is not only for paid learners. Whenever your subscription will be over, if you are the free learners also, then also this test series available for everyone. That's why I made it free of cost. This PYQs test series is free. But CS paid mock test, where I am giving expected question, where I am creating the test, upcoming exam, whatever the not PYQs, not UGC NET PYQs, those are only for the paid learners. But this is available after your subscription also. And that's why I am telling you, downloading PDF will be not helpful. Rather than that, attempt the test. No, that little time is there, 10 minutes, 20 minutes, attempt one small test. You have 1 hour, attempt 3 to 4 tests. You have 2 hours, attempt full length. How many times you will attempt the test series, your accuracy, your revision, your time management, everything will improve. This time, how many test series you will attempt, your score will improve. I am telling you. Study means with PDF, by watching recording, nothing. This time, completely focus on more practice, practice, practice. And through the test series only, your practice will be good. Whenever all PYQs practice is done, then go for the all paid mock test series. Every day, 1 day PYQs, 1 day paid mock test. There also unit wise test is available, full length test is available, 20 question, 30 question, 40 question, 100 question, all are available. Unit wise also, full length also. Please do that. This is very, very important for you. Okay, must do this. ठीक है? So I hope you like this class. It is beneficial for you. So एक like, share, subscribe तो बनता है. Please like, share, subscribe and let me know in the comment section the topic list. How many star you got? High priority to low priority. Make a order. Yes, these are the topic I got. This many stars. So that is the most important. Must let me know in the comment section. Thank you. Bye.